In the last lesson, we multiplied a monomial by a polynomial. We can multiply either two binomials using a method called FOIL, or using the same process, we can multiply two polynomials, and it's all using the distributive property. Now, we could make this look like the numerical multiplication where we use 2 for 2-digit numbers and line it up vertically. So I'm going to take a negative 4 times the 8 is negative 32, and negative 4 times y is negative 4y. And then we could multiply y by both terms, so y times 8 is 8y, and y times y is y squared. We can add straight down. We're going to have, there's a negative 32, 4y, and y squared. Now, that method isn't used real commonly. More commonly is to use a horizontal method. So just like we did before, we're going to take the first term times both the other terms, and then the second term times the other two terms. So y times y is y squared, and then y times negative 4, and then same thing, we're going to do 8 times y, and 8 times negative 4. So now when we go and combine like terms, the y squared doesn't have a like term, so it just stays the same. Negative 4 plus 8 is going to be positive 4 minus 32. So I got the same answer both ways. The vertical method may look familiar from doing multiplication of 2 and 3 and 4-digit numbers that you did in elementary school or middle school, but more commonly used is the horizontal method. And there's even an acronym for that. It's called FOIL. So FOIL stands for first, outer, inner, last. So they did x plus 3 times x minus 2. So first they multiplied first, so x times x, and then inner, 3 times x, and then outer, and then last. And of course it doesn't matter the order that we multiply in. As long as we get all of our products made, we're going to get the same answer. So the exact order of FOIL isn't essential. So we're going to try first. So z times z is z squared. Outer minus 12z. Inner, so minus 6z. And conveniently our like terms end up next to each other. Last, so plus 72. And our like terms is all we have left to do. So I have z squared. Negative 12 minus 6 would be negative 18, z, plus 72, and we're done. So very quick problems. First, so we have 10x squared, outer, plus 40x, inner, minus 8x, last, minus 32. And I can combine my like terms. So I have 10x squared, 40 minus 8 is 32, x minus happens to be 32 there also, and we're done. Now because these are so quick and easy, they had to throw in a zinger, and we're going to look at a geometry connection. The area of a triangle is 1/2. Okay, we know this. The area of a triangle is 1/2 the height times the base. Okay, yep, we know that. Writing expression for the area of the triangle. That's supposed to be a t. So all we're going to have to do is put in, I like my little t, 1/2. The height, they gave us the expression x minus 7 and 6x plus 4. Now, suggestion. Using the commutative property, it doesn't matter what order we multiply in. So I'm going to distribute the 1/2 to the things that are multiples of 2. So I'm just copy down the x minus 7. And half of 6 is 3, half of 4 is 2. Now I've just made my work a little simpler. So first, 3x squared, outer plus 2x, inner minus 21x, last minus 14. So the last thing we have left to do is combine our like terms. So 2 minus 21 is negative 19x minus 14, and there we are. Now, instead of distributing that 1/2 first, we could have multiplied the numbers first and then divide it, put the 1/2 through to everything, but that just gives a lot larger numbers to work with, and I like to make things as simple on myself as possible. Now, I suppose it was an area problem, so we should label it. They didn't give us a unit. I'm going to call it again, meters squared. It's a real unit. Okay, the acronym breaks down, but I'm still going to use the same process. I'm going to take the 3a, my first term, and I'm going to multiply it by the 3 terms in the other polynomial. So that's fine. So 3a times a squared is going to be 3a cubed minus 36a times a is a squared plus 3a. And then we're going to have plus 4a squared minus 48a plus 4. And all we have left is to combine our like terms. Now I kind of, by habit, went ahead and lined up my like terms vertically, which is kind of handy. I got used to that from using the squares to do our work in. Negative 36 plus 4 would be negative 32. A squared. 3 plus negative 48 is going to be negative 45. And plus 4, and there you are. So I'm going to do the same process with a trinomial. First term. So I've got 2b squared times b squared is going to be b to the 4th. Plus 2 times 3 is 6. B cubed. And negative 2b squared. And we're going to take the 7b times all 3 terms. So we're going to have 7b cubed plus 21b squared minus 7b. And I'm out of colors, so I guess I'll go back to white. So we have 9b squared plus 27b minus 9. And once again, I lined up my like terms vertically, which makes it very handy. So I have 2b to the 4th. 6 plus 7 is 13b. Negative 2 plus 21 is 12. Plus 9 is 21b squared. Negative 7 plus 27 is 20b. And minus 9. Oops, left off my cubed. I'm in the 13b cubed. It was there. Just forgot to write it down. Never hurts to double check your work. Found it. And you can notice the pattern. I should have noticed that as I was writing it, but I was talking at the same time as writing. So there's my exponents. 4, 3, 2, 1, none. The FOIL method is the sum of the products of the first terms, F, the outer terms, O, the inner terms, I, the last terms, L. The distributive property can be used to multiply any two polynomials. They don't have to just be binomials. Bah!